Hi, my name is Kaspar Skatka, and this is my Project 2 crop farming simulator. So to begin, I'd like to go over the inheritance relation between all of my classes, and then I'd like to go through each class individually to see how they're implemented in my game. The base class that we have is called Crop, and the two classes inherited from it are Cactus and Flytrap. These two classes are the actual plants that you play in the game. Now to look at Crop.h. Crop serves as a foundation for Cactus and Flytrap. It houses the actual statistics of the plant, such as health, max health, the current maturity, the max maturity, etc. And it also houses the different status effects that affect the plant. There's a Boolean variable for if it's happening or not, and there's also a counter for each one of them that shows how many days are remaining for the certain event. There's also the player interaction values. So when the player wants to water the plant, whatever watering is equal to will be added to the current water value. There's also a lose token and a win token. These are just nice to have because it adds a certain level of modularity to the actual ending of the game. There's also some, in the public scope here, there's also some getters. There is the load game, which is universal for every function. There's a default constructor. But these two are the important functions for the game. The first one, user input, is basically just running through the input cycle where the user can choose to water, fertilize, save, do nothing. And the next day comes after that, which runs through the internal workings of the game where you do a bunch of checks to see if the plant has perished, you reduce the water or fertilizer levels, you check the energy levels, you do everything that affects the values of the plant. And the save game function is about the same for each class, but there is a minor variation, which is important for the main function. Now to look at crop.cpp, the load game file is pretty standard. You open the save game file, you check if it's not found, and then you just load in the values from the savegame.txt file, and then it'll continue the game where it left off. Now looking at the inherited classes, we can see that this is where we implement the user input, the next day, and the save game function. In cactus.cpp, we initialize the cactus plant with all of these different values. It's important to note that the drought counter is equal to random. This is basically prepping the next instance of a drought, for instance. It's prepping the next occurrence of it to have a certain amount of days. For the save game file, the notable thing within this is the fact that it prints a 1 at the beginning. This helps the main function recognize that this is a cactus plant, and therefore it should create a new cactus object. Now here we get to the user input function. The bool clear token is a conditional modifier that towards the end, if it is true, it'll repeat through this, and it's basically for the formatting of it to make it look nice. Now where it says printing the UI, this is basically a bunch of lines and such that the console has printed within it, and it creates a nice user interface. This will be seen multiple times throughout the code because I have to clear the console output and then redraw it with new values. So anytime this is seen, this is just the user interface basically. this is where we get the user input. If it is any of these, W, F, R, if a bug infestation is there, or N, then it'll do whatever these say. And if none of them are true, it'll clear the screen and reprint this and tell them to try again. You can also enter S to save the game, and then this draws a bunch of stats and stuff. Boom, 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 bunch of stats. And then if it's equal to W, you water, F, fertilize, R, you remove a bug infestation, N, you have no action taken. But if you press the save option, S, it'll call the save game function and exit the program. And then this is basically saying, if none of these are true, you recursively call this function again with true, which will clear the screen and reprint it. This is also just the menu, the user interface, sorry, where it does all the stuff again. And here it'll say, towards the bottom, it'll say drought, days remaining, and then drought counter, and it does it for all of those, which will let the user know what they have coming up. And so that's it for the user input function. It's basically just doing one user input. It'll tell you what you did, and then you continue to the next day function here. Now next day adds, first of all, adds a max +1 to max maturity, and it'll check instantly before anything happens. If it reached the max maturity, which is equal to 20, then you win. And so current water level, this will basically, every round you lose water, you lose fertilizer. If it's within a certain threshold, different things will happen. Each plant has a lower, a critical, and an upper threshold for their water, fertilizer, and energy levels. The lower threshold means you lose a little bit of energy or health. The critical threshold means you lose a lot of energy or health. And the upper threshold will always make you lose health because it's really bad for the plant structure. And so we're basically just running through doing a bunch of checks for the water, fertilizer, and energy. And this is where we get to the different status effects to see what they do. The status drought, when it's equal to true, makes our effectiveness of watering go down. And each turn that this happens, the drought counter gets subtracted by 1. And when it reaches 0, normalcy gets returned and it gets set to false, and it prepares the next instance. Just like when we initialized all of our values in the constructor, it prepares the next instance of this. And the same can be said true for pretty much every other status effect, except for the bug infestation. The bug infestation is permanent, no matter what, until the user removes. And the unique thing about this is it has a chance to do heavy damage, so you can gamble and keep it there if you have to focus on something else. Or you can get rid of it instantly, but lose that turn in exchange for that. And all the way at the end here, we have a dice roll, basically, that says if none of these are true, or whichever ones of these are not true yet, see if we get an unlucky dice roll and then set them equal to true. And then on the next turn, the effects will occur. And way at the end here, after all the health gets subtracted, it'll check if it's less than or equal to 0. And if it is, then the cactus has perished, better luck next time. And it'll exit the gameplay loop. That is essentially the critical functionality of the game. There is not much else different within the flytrap class. It is mostly copy and paste, but there are a few notable exceptions. In the cactus class, in our save game function, you could note that it output a 1 as the first value output. In flytrap.cpp, the first value output is 0. This is so that main can tell if it's a 0, create a flytrap object. If it's a 1, create a cactus object. And so flytrap is initialized with slightly different values. It's a little bit more fragile, but that comes with a benefit as well, which we will soon see. This is the user input function here. Essentially the same thing. Obviously cactus is replaced with flytrap wherever applicable. There are also slightly different effects for each plant. For instance, with the flytrap, the cold snap is not quite as effective as it is on the cactus because cactus are very susceptible to the cold. Um, but I believe the flytrap is more fertilizer sensitive, which means it starts with less, and the thresholds are much smaller. And droughts affect it a little bit more harshly because they have a terrible environment to live in. In the user input function here, the notable difference is whenever the user inputs are, instead of just removing the bug infestation, the flytrap actually consumes the bugs and gains +7 fertilizer. As you can see here, in the next day function, the compared to the boundaries or the thresholds for the cactus, the fertilizer thresholds are a little bit more, extreme. You have a smaller positive threshold, where it's healthy. The thresholds where it is unhealthy are much higher. See, lower fertilizer 14, 16 for critical. You'll reach those much quicker unless you get those bug infestations. And all of this is really the same. Besides the effectiveness of the events, there's not much else. And this again is just preparing, or this is rolling to see if the status will become true or not. So now that we have taken a look at the user input, the next day, the save game, and the load game functions, we can finally look at how the gameplay is implemented in the main function. This here is a welcome prompt. It's the first thing you see when you boot up the game. This is the loading bar. It's just a cool loading bar I got some help with, and it just looks aesthetic. So in the main function, we have bool restart token. At the end, when the game is either won or lost, the game will ask you if you'd like to try again. And if you want to, this gets set to true, and it restarts this. Restarts starting at the do loop. So we have string input, int input. These are just for functionality. So we first create a pointer to a crop plant, and we set that equal to null pointer. We create a input file stream object. We do the welcome prompt. We take the first input to see if that first value is a 1 or a 0. And if we decide to load the game, we reopen the object because we need to read that value in again, so there's a temporary variable for that within the crop class. That would be isNormal. It's not actually used, it's just a temporary variable to soak that input basically. And so if int input from that first value is equal to 1, then we make a cactus. If it's equal to 0, we make a flytrap object. Then we close, and then we reopen and load the game. And then else if, we do the same thing if it's a lowercase l. If it's a new game, we clear the screen, and then we say select your plant. Input 1 to select cactus, or 2 to select the Venus flytrap. And then if it's equal to 1, we'll new cactus, flytrap, simple. And then else if it's a invalid input, then bad inputs equal to true, and then we repeat this. And if none of the inputs are true or valid to begin with, for L or N, we clear the screen, we say invalid input detected, please restart the game, and we exit. After all of that is done, we clear the screen, we do the loading bar, and then we move on to the actual game loop here. So basically, plant while the win token is not equal to true, and while the lose token is not equal to true, we first get the user input with a false so that we know we don't have to go through that repetition again. And then after we do the user input, we go to the next day function, which will update the values, and then we loop back to user input. And next day is where the lose token or the win token can potentially get set equal to true. So it will break from that before we get to the next user input. Then after all that is said and done, when we've won or lost, we delete the plant object, and then we say, would you like to play again? Enter Y for yes, or anything else for no. Take the input, if it's equal to Y, restart token is equal to true. If it's anything else, restart token is equal to false. And then we repeat if restart token equals true. All the way at the top of main, right there. And then after all that, we clear. And eventually, when they do not want to restart, we're done with the game and we return 0. Now to take a look at the actual game itself. So this is the welcome prompt. Welcome to Kaspar's Crop Simulator, TM. This basically gives a rundown of the game. The objective is to guide it to maturity before its health runs out. We can directly influence water and fertilizer, and when they become too low or too high, our energy levels will decrease. When our energy becomes too low, you'll begin losing health, losing if it reaches 0. These are the events that influence the game. Droughts reduce the watering effectiveness. Heavy rains flood the plant with water. These can be beneficial but also dangerous if you have too much water. The heat wave increases water loss per day. Cold snap deals direct damage to health. That's the most dangerous one. And the bug infestation has only a chance to deal damage, but it'll last until it's removed. If you wish to start a new game, input N. So we'll start a new game. Then we can select our plant here. I'm going to go ahead and go with cactus. And then we're loading the game. So here's the user interface. We can see this is our input options at the top. Our current stats are all right here within the current stats box. And we currently have no events happening because it's the first day. So let's say we want to water the cactus, input W, water the cactus. We can fertilize now. So now we have two status effects at once. We have heavy rains, which is beneficial for us right now, and a bug infestation. I'm going to go ahead and get rid of the bug infestation first. We got another bug infestation back to back. That's unlucky. I'm going to go ahead and fertilize because our water won't go down too much. Now here we can see the cold snap is really dangerous to the cactus, but the drought is ineffective, which means I'll actually go ahead and water because it's not very effective. So we're on day 7 and our health is 90. We got another bug infestation, so we should probably just get rid of that quickly. Or the fertilizer, I should probably be getting that up right now. Right now we're doing really well. We're getting pretty lucky with these heavy rains. Heat wave is also ineffective, of course, because cactus are heat resistant. I'll go ahead and remove the bug infestation again. The Our water level needs to get up too. fertilizer. So now we're at the point where we're too far gone. And so we should just try and mitigate the damage and see if we can hold out till the end. At this point, I'm just going to spam fertilizer because our water level is never going to get back up. And it looks like we win. Cactus has reached maturity. Great job. Would you like to play again? Sure. If you wish to start a new game, input N. Go ahead and do that. We'll do a Venus flytrap this time. And I'll go ahead and show bad gameplay. And we'll see how the save functionality works here. So I'll just spam no input. See, it says no action taken. Now if I hit S, game saved, now exiting. So we'll relaunch the game, hit the load input, and it'll load the current state of the game. Then we can see everything is saved, it's the same thing. And we'll just try and lose here. So our health is at 8, which means the next turn should be the lost. Oh, we have 1 HP. There we go. Fly trap has perished. Better luck next time. Answer Y for yes or anything else for no. We'll go ahead and hit no this time. So that is the game. It's basically about mitigating the damage and trying to see if you can prevent your plant from taking damage for long enough to pull out the victory. And that is pretty much it. Thank you for watching and have a great day.